Today we're going to talk about function characteristics and the different notations that we can use for those. So on number one, it's asking for the domain. So domain would be all of the x's that are represented in this graph. So in this case, we see that this graph looks like it stops at -3, and it looks like it stops at +3, but since it has arrows on both ends, it's going to keep going to the left forever, and it's going to keep going to the right forever. So it keeps going to -infinity and all the way to +infinity. And so when we're talking about infinity, we can't actually touch infinity, so we're going to put parentheses like we did here. And the problem with letter C is that they go from largest to smallest, and we never want to do that. We always want to go smallest to largest, smallest number to largest number. So that would be letter B. Another way to write this would be all real numbers, or sometimes they use the all real numbers symbol. Okay, number two, we're looking for where it is increasing. So it's increasing on this left side, and then it stops increasing at the vertex. So when we're talking about increase and decrease, we use the x values, just like with domain. So this starts increasing when x is -infinity, and then it's going to keep increasing all the way to -4. And then after that, it would be decreasing. So we would say everything less than -4. So we could say -infinity to -4. We would not include -4 because -4 is a turning point. At that point, it's not increasing or decreasing. So we would say -4 or -infinity to -4. This one is an inequality notation, so that would just mean all the x's less than -4. Okay, find the x-intercepts in set notation. All right, so x-intercepts here where it crosses the x-axis, so at -4 and +2. And when we do that, with set notation, you put them in braces like we do here. That's not a coordinate. This is just listing out the different x-intercepts. So another way to write it would be -4, 0, and 2, 0. These are two separate coordinates. This is just listing out what the x-intercepts are. All right, and then find the range. So range, instead of the x's, now we're looking at the y's. So we want to know the lowest y value to the highest y value that this graph uses. So the lowest y value that this graph uses is -9. There's nothing below -9. And then it keeps going up and up and up forever because of that arrow. So it goes up to infinity. So we always want to go lowest to highest. So it goes from -9 to infinity. So it's going to be one of these. Since there is an actual point at -9, so there's a coordinate -1, -9. -9 is included because it is part of this graph. So we're going to put a bracket on one side and a parentheses on the other. All right, number 5, find the positive interval in inequality notation. So positive means it's above the x-axis, so it has a positive y value. So anytime they say find the positive interval, that's talking about a positive y value. But when we're looking at the interval, we write down the x values. So we're looking at where it has a positive y, but we're writing down the interval in terms of x. So this little section here, this little hump at the top, that has a positive y value. Right, so we look at that interval, that's from where x is -3 to x is 1. Right, at these coordinates, it's not positive. At these coordinates, it's 0. So we don't include those in the positive interval but it'll be everything in between those. So from -3 to +1. So it's gonna be one of these over here. X is in between -3 and +1. But we don't want to include those numbers. We're not going to put equal to, it's just going to be -3 less than X less than 1. A and C are actually describing these little legs down here. When it says X is less than -3 and X is bigger than 1, all the X's that are bigger than 1 and all the X's that are less than -3, that would be the little legs of our parabola. So those would actually describe our negative intervals. So we don't want those. Just be careful about which direction your inequalities are pointing. Right, number 6, we're finding the range in set notation. All right, Sally is offering t-shirts to her club members to purchase. She will buy a shirt for herself and she will buy a maximum of 5 shirts for the other 4 members in her club. The t-shirt company charges $15 per shirt as well as a $10 design fee. All right, so if we were to make an equation, they're charging $15 per shirt and that $10 design fee. So for these, we're trying to find the range. Our domain would be 1, 2, 3, 4, or 5. She knows she's going to buy a shirt for herself. And then she could possibly buy 4 for her other 4 members. So she could buy 1, 2, 3, 4, or 5 shirts. That would be our domain. Remember, your range is based on your domain. So if we plug in a 1 for X, and we put that in our calculator, 15 times 1 plus 10 is 25. And then we plug in a 2 for X, 15 times 2 plus 10 is 40. And then we keep that pattern going. We have 55, and then 70, and then 85. So this represents our range based on the fact that she could buy somewhere between 1 and 5 t-shirts. We wouldn't use interval notation here because she can't buy 1.5 shirts. So we don't want to say that she could possibly buy 1 to 5 because that includes everything in between 1 and 5. It includes 1.5 and 2.5. So we don't want to write it in interval notation. We want to use set notation since these are whole numbers. And so our range would be letter D.